When we have two lines that are parallel to each other, that means the two lines never intersect. I'm putting an asterisk here for those of you that have investigated non-Euclidean geometry, but for our purposes today, two parallel lines never intersect. When we take those two parallel lines and we draw a diagonal line going through those two parallel lines, that diagonal line is called a transversal. And when we draw a transversal through those two parallel lines, we create eight angles. And those eight angles have a very consistent relationship between them. And if you haven't already familiarized yourself with those relationships, you need to pause the video and go familiarize yourself with the four really big relationships. And those are corresponding angles, same side interior angles, alternate interior angles, and alternate exterior angles. Go familiarize yourself with those big four because we're going to need that information in order to answer these problems today. But the amazing thing about these eight angles that are formed when you draw a transversal through these two parallel lines is that if you know the measurement of just one of these eight angles, you then have the ability to figure out the other seven. So just knowing one of the eight angles is all you need to figure out every other missing angle. So in this first problem, we are given our two parallel lines in our transversal, and the angles are very helpfully numbered 1 through 8. And we're told the value of one of those angles, angle 7, we're told is 125 degrees. And then we're asked specifically for the measure of angle 2. And as I said, we could figure out any of these angles that we want to. If we know these big relationships that I mentioned, those four main relationships, we can figure out any angle, but we just want angle 2. So let's see how we're going to go about doing that. So the first thing I'm going to do is just go ahead and label angle 7 as 125 degrees. And then the angle that we want to know is this one right here, the measure of angle 2. So you may already know what kind of relationship these two have if you've studied the four main relationships that a transversal forms, but sometimes it can be a little tricky if you haven't like really memorized them to figure out what they are. So a way that you can sort of remember how to identify these relationships is start by looking at the two parallel lines and ask yourself, are the two angles that we're looking at, are they inside the parallel lines, meaning in between the two parallel lines, or are they outside the two parallel lines? If the angles we're looking at are in between the two parallel lines, we call those interior angles. Now, these two angles we have, angle 2 and angle 7, are not in between the two parallel lines. They're on the outside, and so we call these exterior angles. So angle 2 and angle 7 are what we refer to as exterior angles, along with their counterparts. Angle 1 and angle 8 are also exterior angles, and so of course angles 3, 4, 5, 6, those are our interior angles. So these are exterior angles. Now, what kind of exterior angles are they? There are two different types of exterior angles that we have, and the way we can figure out what kind of exterior angles is by looking at our transversal. That's this diagonal that runs through. There's the transversal. So the question we're asking ourselves now is, are these two angles that we're looking at, angle 2 and angle 7, are these angles on the same side of the transversal? Meaning, are they both on the left side of the transversal or are they both on the right side of the transversal? Or are they on different sides of the transversal? If they were on the same side, like if they were both on the left side of the transversal, like angle 1 and angle 7, we would refer to those as being same side angles. Angle 2 and angle 8, also same side angles. But these aren't. Angle 2 and angle 7 are on opposite sides of the transversal. We've got one on the left and we've got one on the right. So we could call these opposite angles, but the word we use in math is actually alternate. Alternate angles. So we refer to this pair of angles, angle 2 and angle 7, as alternate exterior angles. Now, the thing that you need to know, and maybe you can tell just by looking at the shapes of these angles, although it's dangerous to go just based on looks. So, one thing that you should know, if you don't know already, one of these things you should commit to memory is that alternate exterior angles are congruent. And congruent is also a really important word that you probably already know. But if you don't already know the word congruent, congruent means they are the same. Alternate exterior angles are the same. So that means the measure of angle 2 is going to be equal to the measure of angle 7. And we know the measure of angle 7 is 125 degrees. And so that means the measure of angle 2 is also going to be 125 degrees. So that was a really long explanation to tell you that they're the same, but it's an important explanation because the hardest part of this is being able to tell what kinds of angles are the two. In this case, the types of angles or the relationship the angles have is alternate exterior. Okay, let's take a look. Let's take a look at another set here. So we want to find angle VWZ. And if you're not used to angles being written like this, meaning written with letters instead of numbers, angle VWZ means whenever we identify this angle, we connect the points in that order, meaning we start with V, so right here, then we go to W, then we go to Z. So we connect them in that order, V, W, Z. The letter that's in the middle here, W, is always going to be the vertex of the angle. The vertex means the middle, the point where the angle bends. That letter in the middle is going to be that part of the angle. So why can't we just say angle W then? Why do we have to say angle VWZ? Well, a transversal forms 8 angles, and 4 of those angles could be called angle W. The one that we want is the one that I outlined right there, VWZ, but if I just called it angle W, how would you know that I was talking about that one and not this one right here? Or this one right here? Or this one right here? So we need 3 letters to name this one so we know which of the angle W's we're talking about. Okay, so VWZ, that's the one we want. Well, easy, it's 3x, done. So, of course, 3x is not a measurement. I need to know how many degrees that is. It's 3x degrees, but I need to know what x is. Well, I do have these 2 angles right here, and I could figure out what x is from those 2 angles if I knew what kind of relationship those 2 angles had. So let's again look at our parallel lines. There's our parallel lines. And these 2 angles, this time, the 6x and the 3x, those are inside. Those are between the 2 parallel lines. So these are going to be interior angles. Interior. And then we'll look at our transversal. That's the diagonal line that goes through the parallel lines. Our transversal is going to tell us whether these are same side or alternate angles. So are these both on the same side of the transversal, or are they on alternate sides of the transversal? Obviously 6x and 3x are on the same side of the transversal, so we refer to these as same side interior. So this is another one of those things that you just need to know. You need to know that the relationship between same side interior angles is that they are supplementary. Same side interior angles are supplementary. What does supplementary mean? It means they have a sum of 180 degrees. What that means is if I take these 2 angles, 6x and 3x, and I add them together, the total, the sum, should be 180 degrees, and that's how I'm going to figure out what x is. I'm going to take the angle 6x, I'm going to add the angle 3x, and the total should be 180. Now remember, 3x is the thing that I want. That was the angle I was looking for. How big is 3x? I can't tell. There's my VWZ again. Remember, that was my angle. I can't tell what it is until I know x. Easy enough, though. Let's go ahead and let's combine our like terms. 6x and 3x we can combine to get 9x. So we've got 9x equals 180, just combining our like terms. And then to isolate the x, we'll just use our division property of equality. We will divide both sides by 9. 9x divided by x is 1x, and 180 divided by 9 is 20. And it's so tempting to go, oh, x equals 20, I'm done. But the problem didn't ask what's x. The problem asked what is angle VWZ. And VWZ was that 3x. So we need to replace the x with our 20. And 3 times 20, 3 times 20 is 60. So the answer to this problem is 60 degrees. So we don't want to get too excited and get x equals and think we're finished. Go back and look at the question, make sure we're actually answering what the question asked, which was, what's the value of this angle, not what is the value of x.